Very good day to everyone and good morning. So my name is Tharmigan Nadarason and I'm 19 and I'm doing electrical engineering in University of National Malaysia, and my matrix ID is AA201143. And today I'm going to be doing my presentation, Orcad presentation here, and it is about Lab 3 Activity 1. And first of all, I would like to apologize to you guys due to some technical errors in my laptop. Due to some virus, I couldn't open my Orcad software, so I will be doing my presentation in these screenshots. These are screenshots that I done for my Lab 3 project. I done that, and luckily I have screenshot those for my report back then when I had to submit it. So today I'll be doing my presentation using this. Hope you don't mind, guys. So first of all, I'm going to present the Lab 3 Activity 1. So first of all, let me give you a small introduction about DC swipe analysis, which is the title of the Lab 3 Activity 1. So DC sweep analysis is used to calculate a circuit's bias point over a range of values. This procedure allows us to simulate a circuit many times, sweeping the DC values with a predetermined range. You can control the source values by choosing the start and stop values and increment for the DC range. The bias point of the circuit is calculated for each value of the sweep. So now I'm gonna tell you the process, the DC sweep analysis process, using these following things. So first of all, the DC operating point is calculated using a specific start value. The value from the source is incremented, and another DC operating point is calculated. The third one is the increment value is added again, and the process continues until the stop value is reached. Then the result will be displayed. So now let's get to this construction area. So if you see here on the left here, this is the ADC, and these two will be the resistors, and the middle one here, this is the independent current source, and this is here is a R load, resistor load, and this one here is the ground. So if we simulate this circuit, would get our results. Now let's get on to the results part. So these are the results. So if we simulate, we would get these results. So first of all, let's get on to the second graph first. So the second graph is here to find the power delivered at 1.8 ampere. So that 1.8 ampere will be here, approximately will be here, and the value here is 25.920. So this is the value. If this is the value we would get if we simulate it in our software. So let's get on to our first graph. So the first graph is to find the V load when the V in is 10 volt. So the 10 volt will be here, hence our value will be 12 volt. So the V load will be 12 volt when the V in is 10 volt. And I would like to say sorry to you guys again, because I couldn't show the simulation part to you guys. It is a bit of a process that we should do to find this. I was not able to show you guys because of some technical errors, and I'm really apologize, and I hope you guys don't mind. And I'm really sorry. I really apologize for you guys for that. And so from this graph, we can clearly see that V load and power delivered is 12 volt and 25.920 respectively. And I hope this presentation will give you an enlightenment about this activity lab 3. Thank you so much. That's all from me.